Hi, everybody. Welcome to the webinar about building AI applications using new machine learning capabilities of MongoDB. My name is Costa. I'll be your host today, and I'm really excited to introduce you the main speaker for today, Jorge Torres, the CEO and founder of MindsDB. And MindsDB is one of the fastest growing open source AI platforms today. It helps developers quickly and easily build AI solutions by integrating AI capabilities into data platforms. And before Jorge joined MindsDB and founded MindsDB, he did research and was teaching at UC Berkeley for machine learning automation and explainability, and was involved in large healthcare projects, machine learning projects for US government. So I hope you will really enjoy the webinar today. There are many interesting demos ahead. You will be able to see how to build cool stuff with the latest NLP uh, pre-trained models and MongoDB. And feel free to ask questions during the webinar in the questions tab. It's on the bottom right corner. And we will, at the end of the webinar, we will answer all the questions. So now I will silence myself and hand over to Jorge.
Thank you, Costa. So I really appreciate the intro and everything that Costa has said is on the spot. When my co-founder and I started MindsDB, we realized that the world of data had been around for a long time. People that created databases knew exactly how to do it well, and data preparation and etc. is a very important task for machine learning. So we decided that rather than bringing and extracting data to machine learning should be part of the data layer, especially for applied use cases. And that's what we're going to cover today. So one of our favorite databases are databases that can really identify a problem that developers have and then solve that problem the most effective way. And MongoDB is certainly one of those, where developers had the need to store information in documents and then exchange this information back and forth from web applications without having to kind of extract, decode, code into JSON, go back and forth. So we really, really like the approach that Mongo has had, and we've been big fans from the beginning. And we thought, well, doing machine learning on document data, it's it's a task that is not for everyone to solve, but everyone should be able to do it, and that's what we brought to the table. Let me bring you more intuitions into this. MindsDB wanted to build itself as an enabler of machine learning capabilities by sitting natively in the way that people build applications. So you have like the client application, and then the client should speak to the database. And then MyZB portrays machine learning models as collections in the case of Mongo, so that developers that are building stuff with MongoDB can now augment their applications with ML without having to change too much the way that you guys do stuff, or the way that we do stuff, because we also use Mongo ourselves. So a little bit of background. The MLOps lifecycle traditionally, or the steps that people have to follow to do machine learning, are the following. You do data preparation, which is data acquisition, data cleaning and labeling, feature engineering. And then from there, you go into a model, and you go actually back and forth between the feature engineering and the model generation selection. And then eventually you have a model that you like, and then you want to move this model into production. And then you want to consume this model and then improve this model as you collect more data. So this cycle is essentially what people follow through. But a lot of the steps that people have to go in order to complete this are designed with the hat of a machine learning engineer or researcher. And many of that carries from the things that people do when they're doing their PhD or their I don't know, their educational process of machine learning. But applied machine learning should be a little bit different. So if you think of this part, people end up what people end up doing is they end up extracting data. Say, for instance, they have a whole bunch of documents and then they start massaging this in Python using pandas, etc. Now, when you're thinking about JSON in particular, there's no better tool than doing this in Mongo. Like, why would you not upload everything into Mongo and then do the data cleaning and labeling and feature engineering inside of Mongo? Because Mongo actually provides all the capabilities to do this. But people don't necessarily do this because they have the mentality of the researcher in mind, and they forget that there are databases that do this data preparation effectively. So um, the message here is MongoDB, if your data is documents, is the best place to do feature engineering data preparation, in our opinion. And then the job of MindsDB is that you can do the model and optimization and all that, and even serving the model all inside one single uh, environment that is as natural to Mongo developers as possible. So um, there is the problem of once you have a model, um, then if you did everything outside the database, every time you want to run the predictions, you're going to have to extract data from where the data is at, in this case, Mongo, and then transform it so that it is the way that the model needs it. And then many of these applications, if you're thinking of the web application, etc., they cannot consume this directly, and they cannot even uh, call the transformation pipeline. So you're going to have to do this ad hoc. So you're going to extract, load into the model, then get the predictions back into Mongo, and then actually your application can consume them. So the idea behind MindsDB is, well, let's allow people to do modeling directly from data in Mongo, and then consume this directly. So as soon as they create the model, that they can consume this from the same data layer, and therefore you save a whole bunch of unnecessary ETLing. And that's why MindsDB became such a popular open source project. Now, data preparation, in our opinion, there's, I said before, if you can leverage as much as possible the Mongo query language, then you can understand, as probably all of you do, that is super powerful for data preparation and feature engineering. And at the end, each item within the JSON document that you have, it's a feature, and then you should be able to do machine learning with this. What we're going to do now is I'm going to explain to you that a lot of the ML use cases that people have could be solved with this abstraction. So um, let's start with machine learning where it actually belongs, which is in the data part. And let's call this in database machine learning. And for instance, you can do forecasting a la MongoDB. One example is you have the features for all your either classification, regression within semi-structured data in Mongo, and you want to set up a model that can do the forecasting for you. So let's think of, for example, you want to forecast the units in stock for all products across all stores. Then MindsDB will let you create and train a predictive model from a collection and query the model as if it was a collection to get predictions. What does this mean? Like, and this will all become intuitive once we go through the demos. But I think that the takeaway here is by being able to bring the models as if they're collections, then you can query the same thing from the model as a collection, and what you get in result is predictions. And therefore you're not going back and forth between the where you deploy your model and piping data to this model. These models are aware of where to train the data, where to update, etc., etc. Let's go into, for instance, forecasting stock. You have your data in Mongo that looks like this. So you have product and you have the store, the units in stock, and you want to forecast this. In the MindSB approach, you could create a model with a very simple statement, which is inserting into the predictors table, and then given the name of the model that you want to have, the what you want to predict, and where or what collection you are going to train from, and then you can give it some parameters as to the time series information. And then you can consume this model the same way that you will consume a table. So you say, okay, I want to query from this model. In this case, I'm going to define. I'm going to tell it what timestamp, what product, and then the stock price, and then depending on that, just give me some forecasting, and then the results are given back to you as if they were Mongo. Anyway, I think that This is just a very quick example, but what I want you to understand in the following examples is that you can bring all the power of machine learning through MindsDB to Mongo, including NLP, now GPT, etc. And it is super powerful. So with that, I will hand it over to Costa, and he's going to give you a guide through our demo.
Welcome everybody to this MongoDB webinar. I'll be showing you how to get set up and also taking you through 3 separate use cases. My name is Tom and I'm the engineering manager here at MindsDB. Okay, so if you can see my screen, here are our docs. We've just got ourselves over to the MongoDB Compass section. So first things first, we need to download Compass. And for me, this would be Ubuntu, tab, and download. Go back here. Just a quick overview of how this is going to work. Compass, we're going to connect that to MindsDB. And from MindsDB, we can connect to your database. So I'll just grab Compass up. So here's exactly what it would look like when you have downloaded it. So we need to click on New Connection, Advanced Connection Settings, and here we just need to put in our host, which is cloud.mindsdb.com. This is obviously assuming you use the cloud version, but within our docs, we've got options to use a local installation as well. But for simplicity, I'll just be using cloud. Okay, next up, we click on authentication, click username and password. Username, that is your email address that you signed up with. So for me, it's tom@mindsdb.com. And password. Yeah, and click connect. Okay, now we are into MindsDB. First thing for use case number 1 is to connect to our Mongo database. So we can open up the shell here. And I'll be creating a connection to our MongoDB database. So actually first we want to use MindsDB. So we've got lots of databases already connected, at least in my MindsDB, and we want to be using the standard MindsDB database. And the way we connect databases in Mongo is with a command like this. So db.databases insert 1. And here we put the name we want to use for that database. The engine, in this case, is MongoDB. We also have integrations with plenty of other databases, but we're just focusing on Mongo for now. And then connection arguments. Here is the connection string for our Mongo database, and it's the public database. So this should give me an error. I've already got one. Okay, so let's get started on use case number 1. It's a really simple one where we're going to predict home rental prices. So first, let's switch over to MongoDB. We're just going to check out the data. And we're going to type db.homerentals. That's the name of our table. .find. And we'll just do a limit of 3. Fantastic. So we have lots of information here. For example, number of rooms, number of bathrooms, square foot, location, days on market, neighborhood, rental price. Okay, let's now create our model. It's a little bit of code here. It's nothing major. Well, actually, first let's quickly switch back over to MindsDB. Oh, so we want to create a model now that uses this table. So db.models this time, and we're going to insert the name of the model is what we're going to call home rentals model Mongo. Connection, that's the database that we're going to use, MongoDB. Select data query, so that's just in order to select the data that's in that table. And then we give the column that we want to predict here, predict rental price. So I think this has already been done. So I'll do the quick demo. Oh, let's try 3 and 4. There we go. So once the model has been, once the query has been sent, we get acknowledged true and the object ID. So we can check on the status of that model. So this is in Blue Peter style, one I created earlier. It should say it's complete. Status complete. Let's actually make this a little bit bigger. Alternatively, we can check on that one that we just created now. I think it was _4, and it should say it's training. Okay, training. So we can leave that running for a little while, but in the meantime, let's continue on with this model that was created earlier. Okay, and let's describe the model. db.homerentalsModel.stats. We do scale model. So we now get a description of all the different mixers. So these are kind of like sub-models that were used in order to train the model. So what we do is we test out lots of different model types, and we can see which one was selected by this field here. And it looks like random forest was chosen for this particular use case. Okay, now let's make a single prediction. So we do db.homerentals.find, and we can input whatever parameters we like. So let's make a prediction for square foot equals 83, good location downtown, days on market of 10. Oh, I think I need home rentals model Mongo. Fantastic. So here we get a rental price predicted of 2,910. And we also get lots of other additional variables here, like confidence and the min and max predicted values. Okay, so we've made single predictions. They're kind of could be used ad hoc. But what if we want to do some batch predictions? So with MindsDB, this allows us to join our AI table. So if we consider models as like tables, then making predictions on multiple rows in your like collection is just a matter of joining the model onto that table, or in this case, collection. So once again, we do db.homerentalsModel Mongo, and then we say the collection is this table. And then what we can do is select or say which columns we would like to return and what we would like to return them as. So here we take some of the columns from the initial table, home rentals, and also we can call that real, and also number of rooms, number of bathrooms, square foot. And we can also do the predicted values from the model. So home rentals model Mongo. And what do we want from that? We want the rental price. Let's call that predicted. And let's also take the explain variable as well. So we have a bit more context on those predictions. So let's limit this to 3, so we're not here all day. Brilliant. So for this one, we have a real price of 2271, predicted 2270, 2167, and 2167. Fantastic. And we've also got, as before, all of these lower bounds and upper bounds. Okay, great. So that was example number 1. Let's move on to example number 2. So for this, we're going to do some sentiment analysis, and we're going to use a really cool machine learning framework called Hugging Face. Well, actually, we can use OpenAI, but we have integrations to both Hugging Face and OpenAI, so both are possible. So let's check out the data first. MindsDB. Oh, no, let's use Mongo demo. Brilliant. So db.amazon.find. So this is a collection of Amazon reviews. Oh, Amazon reviews. So we have product name and a review. Late gift, my grandson. He's very happy with it. Easy for him. Sounds quite positive to me. And this one, I'm not super thrilled with the proprietary OS on this unit, but it does work okay. That seems neutral-ish. Okay, right. So just like before, what we want to do is create a model now. First, let's go back to MindsDB. And let's check out this query for creating a model. So we're going to be using the engine OpenAI this time, and we can use all the power of prompt templates. So let's have a look at one of these prompt templates that we've used. Describe the sentiment of the review strictly as positive, neutral, or negative. And we can also give a couple of examples. I love the product, positive, it's a scam, negative. And then here is the review. So this review here has got to match with the variable name in your collection. Okay, let's go. This is already one created. Let's do another one. And we can check the status of this one. Now, since we are using OpenAI, there is very little setup required. The model is already trained and available via API, so we don't need to do any training ourselves. So if we check on the status here, it's this new one that we've just created is already complete. Fantastic. Okay, so let's do a single prediction. So db.model name. We can even do the one we just created. Find, and then review. We input the text in that review variable. Sentiment, neutral, and then here's the review just for reference as well. Brilliant. Next up, just like before, we can do some batch predictions. So we'll do db.model name. And then find, we have to name our collection in this first dictionary. And the second one is what are the variables in their names that we'd like to return. So here we're saying from this collection sentiment variable, let's call it sentiment. No, from the model, the predicted variable sentiment, return that as something called sentiment. And let's also make sure we include the original review here. And again, we'll do just the top 3. So sentiment Mongo, cross-platform Mongo sentiment. Okay, let's try this one. Oh, here we go. I changed the name model, but not there. Fantastic. Okay, so here we are returning 3 predictions. First one is positive, like we discussed. I'm not super thrilled, but it does work okay. That's arguably positive or negative. I think it's pretty good. I purchased this Kindle and this Kindle Fire HD8 was purchased for use by 5 and 8-year-old grandchildren. They basically use it to play Amazon games that you download. Also positive. Okay, right. So that's use case number 2 done. Number 3, we are going to create an OpenAI Twitter bot. So it sounds daunting, but with MindsDB, it's actually super easy. So the first thing to do is create a connection to Twitter. So the way to do this is inserting a database using our Twitter engine. So here we're going to call it My Twitter and use the Twitter engine. And here are the connection args. So if you have a developer Twitter account, these are all accessible there. You need to create a small app and you'll be able to find all these bearer token consumer keys, custom consumer secret, access token secret. Now actually these 4 are only important for writing. So that means replying to tweets or doing standard tweets yourself. For this example, we're just going to use the read functionality, but over the coming days, we're going to add the write functionality to our Mongo API. So anyway, here's an example. I'm not going to hit enter on this because I already have one created. So let's check out use my Twitter to see some data. Okay. So we have a tweets table. Well, in order to view tweets, we let you see them kind of like as a collection or a table. So here's an example, db.tweets, find, and then here you can enter queries to search, just like you would on Twitter, and then create it at, I think this is greater than 2nd of March. So here we're going to find Elon Musk related tweets. Oh, start time must be on or after. Okay, let's go 3. All right, fantastic. Okay, so we've got 10 tweets here. Let's go from the top. Let's just read out a couple. Elon Musk just got fact checked, blah, 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 blah. Author name. We've got all of the information that you can grab from Twitter, from the Twitter API. Okay, let's try another one. And with Twitter, within the sort of search query, you can have sort of Boolean operators. So things like or, and then minus to select whether you want retweets or not. So let's change that created out there again. So here the query says, show me things that have MindsDB or hashtag MindsDB and are not retweets. Okay. So here are a few tweets here. And it looks like a lot of them, well, a lot of these ones, these are links to issues. So for any aspiring contributors out there, we post a lot of our new issues there. And also, here we go, and some more promotion about our hackathon. Again, feel free to get in touch about those. That's all the information is in our community Slack. And some more MindsDB related content here. Okay, cool. So we've been able to view our data. Next step is to create a model. So we need to switch back to MindsDB. And we're going to use OpenAI again. And here is one I created earlier. So what would be a great bot to create with the information that we have so far? So I think something we could do is automatically respond to some of those tweets. So I'm someone that works at MindsDB. I don't want to have to spend all my time on Twitter saying, thank you for your message. How about instead we say, from this tweet by this author, if their comment is a question, invite them to join the MindsDB Slack using this link, join community. Otherwise, simply write a thank you message. So this is a great example of how you can use MindsDB and our OpenAI integration to automate aspects of your life. Okay, so hit enter. We've already got this one already. Twitter response model. We can check on the status. Brilliant. It is status complete. So we are ready to go. So let's make some bulk predictions. So how about we give a response to some of those messages that were related to MindsDB. So we say db.modelname.find. We've got to say our collection, which is my twitter.tweets. Input the query. So this is equivalent to where in SQL. And we input that query string there. And here we are just declaring what we want to be returned, just like before, and adding a limit of 4 there. Okay, so let's check out how it did. Text, just MindsDB Q, and here the response is, thank you for your interest in MindsDB. And here we have save to Notion tweet. Okay, very minimal tweet tweet there. Thank you for your response. Thank you for your support of MindsDB. And it's brilliant. So OpenAI doesn't do exactly the same message each time. I think that's probably to do with the temperature parameter, but that's outside the scope of this webinar. Another one, just a generic thank you. And here, also a thank you for sharing this podcast with us. Okay, let's see if there are any questions. Let's do 10. Okay. Lots of thank you for your support. Thank you for your support. Sharing this podcast with us. Okay. Let's try. Oh, I'd love to see a question here. So maybe let's try. Includes a question mark. See if that works. Okay. Not sure if that one works there. Okay, let's just try. Thank you for your contribution. Interest. Thank you for your interest. Okay, looks like we haven't got any questions at the moment, but anyway, I'm sure you can see the value here. Right, okay, I think that is all in store for today. I hope you enjoyed this quick demo. Feel free to have a play around and get in touch with us on our community Slack if you have any questions at all. Cool. All right. Thanks a lot. Bye.
Okay, so we have a few questions, and I will be answering those. I hope that you guys found this useful. One of those pieces of feedback as well. It is sometimes hard to read, given the size of the letters on this. But we will be sharing these videos, so you can kind of have the kind of like the ability to see this high resolution, as well as everything that Tom did there, and how to replicate this yourselves. Again, all you need to do is create a MindsDB demo account, and everything that he showed there, you can do through the MindsDB cloud, or of course, if you want to do the Docker container and deployment through that, by all means. But yeah. So maybe
Jorge, maybe I will just read the questions and then you can answer. And for the audience, I will share with you tomorrow or today, later today or maybe tomorrow, the scripts that Tom used for the demo. And I already shared in the chat the link to YouTube recording of the demo. It's a little bit higher quality. And yeah, I will also share it in the email. So right now, let's jump into questions. I will start reading them from the first one. And please feel free to ask anything else on the way. So the first question is from Norman. Let me read it. MindsDB, working with data in AWS, S3, or Elasticsearch. I will request comment on it at the end when you answer questions. Can you? Yeah, so Jorge, you commented already for that question. Can you just provide more information as you shared online?
Yeah, of course. So you can connect MindsDB to many different types of data sources, including S3. Even how Tom explained right now, Twitter, and there's like a coming set of other data sources that are not traditional databases. But files in S3 is one that we've supported for a long time. So if you go to MindsDB GUI and add data, and then from there files, you can just point to the URL your S3, and you can do it. There's someone writing an integration for S3 directly. So once you put your S3 tokens for a bucket, then you can see all the files as tables. If you join our community, you can participate on the evolution of that one. But yeah, it is supported, and you should be able to do it. Yeah. Can you?
Thank you. The next question is from Vic Jim. Great stuff on your getting started page. One question: can we choose the type of model, neural network versus tree-based, in the create model command? Wondering the tuning control as well. Thank you in advance.
Yes. So there's the using statement in MindsDB. No, not the using, but the using kind of like sub statements that you can pass on either the insert to models, and you can just select anything about the model that you want. Or when you do like in the SQL style, you can do create model and then using, and then you can pass a model. I do encourage you to join on our Slack and maybe direct me and Patricia, because we're actively improving the way that people can send parameters to the model, such as picking the model, the ensemble of the model, etc. And any feedback that we can get there would be fed into the product, so you can actually be an active participant of the evolution of that feed.
Great. Thank you, Jorge. Let's move on to the next question from Dmitry. How can we add MindsDB to our existing MongoDB cluster? Seems like this demo is about creating a separate MindsDB cluster.
That's a great question, Dmitry. So what we do is that MindsDB looks like another MongoDB instance, just for the machine learning purposes. But You can add it to a cluster depending on how you set up your cluster, using Mongos, like the MongoDB router and sharding mechanism. So we've done this in the past. You can do this because MindsDB speaks the MySQL wire protocol, and Mongos is the way that you can kind of shard into multiple servers. So that way you connect only to Mongos, and then from Mongos, it will redirect the query. Um, it's something that if you have questions, Max Stepanov from our team, he did this in the past, and he can give you more responses. So please join our Slack if you're trying to do this. We will be happy to help you. But yeah, Mongos is the right way to kind of insert MySDB within a cluster, a sharding cluster.
Thanks, Jorge. The next question seems like it's already done by you in chat, but maybe you can expand a little bit more. Nicholas was asking about we demonstrated here Mongo, but is everything here is true for other databases? And what's the particular difference of using Mongo versus other databases? I just rephrase it, but I think that's the question is there some advantages to run on Mongo?
Yeah, so Mongo, it is more about what is your database of choice for the data that you have. So the idea of MySQL is to leverage on databases for data preparation. And you pick Mongo when most of your data is JSONs, or kind of like dictionaries. And depending on what language you're using. But I don't think that there's any better tool than that than Mongo, in my personal opinion. But it is a thing of your choosing. So if you have any other document store and we support it, then you should leverage the database for data preparation. So in the context of this particular talk, we are addressing it because people, when they use Mongo, they have JSON type of data, and again, this no schema or schema-less approach is very effective for like rapid development of applications, but also effective for many other use cases. And if you want to do machine learning on that type of data, then MySQL is the right solution to plug the two. But we support other databases, as Costa was saying. And I think that right now the list is past 70 of those. So yeah, just make sure that when you pick the database, you pick it for what is suitable for your data management tasks, and then the idea of MySQL is that you don't have to worry about now extracting that data to like a different layer, but that you treat machine learning within that data layer as well.
Okay, thank you. And we have new question from Ethan. Let me show it on the screen. What's the best practice of where to do feature engineering while iterating through models with MindsDB? It seems like adding fields to the target data table can be tricky because, for example, these tables or documents are often read-only for folks doing modeling.
Yeah. So the advantage is that you can either send a collection or you can send a query when you create a model. In MindsDB, we have the concept of views as well. So you can create a view from a query and then create the model from that view. That's something that it's available, and therefore, and again, the views or the kind of like this a view at the end is just like a saved query. So those views could be used for you if you don't have right access to the database, because then in MySQL the view is just kind of storing the procedure and translates into like when you run the view is actually running the query under the hood. But yeah, long story short, we believe that view or the concept of views in databases is the right way to do data preparation, especially when you have these type of constraints. And then since those views are stored in not the results of the views, but the saved queries stored in MongoDB, then you can leverage on the fact that you don't need to give access to write access to the database. Certainly, you can do this all MindsDB.
Okay, thank you. Let's move on to the next question. It's from Andrew, and the question is, do S3 compatible storage like NVIDIA AI Store on Minio work too with S3 integration?
I don't know, but we can try it. And if it doesn't, we can add another integration that supports it. Writing integrations to MindsDB is something that a lot of the community helps us do, and therefore, if you speak some Python, then we can show you the ropes. Or I'm sure that there will be someone within community or us that can help you write it if it's not supported.
Okay, thanks. And we have no more questions at the moment. Let's wait a couple of minutes, maybe some will come. But while we're waiting, I just want to mention again that we have community Slack. And whatever questions you have, please join our community Slack. It's on mindsdb.com. It's on the top header menu, the link to join, and you join and ask any questions. You can find Jorge or other people from our team there, and we'll be happy to help all your projects, questions you have.
Yep.
Let me review the chat window if there are any questions in the chat. Yeah, seems like no more questions at the moment. Again, just to mention, we will share the scripts for the demos used and the recording with you via email. So please feel free to share with your colleagues to replay it yourself. Follow the scripts provided. Check out MindsDB docs. There are many useful examples library there of different solutions you can build, and actually the possibilities are numerous. Endless. You can build anything almost. And if you have any idea, please share with us on community Slack. We will get back to you to help you build it. Jorge, any closing comments, questions from your side?
No, thank you, Costa, for organizing this. And again, please join us on Slack. It's the best way for us to communicate and to collaborate. It's a collaborative effort at the end, and ideas, feedback, etc. It's a great place for us to build a relationship. And again, we're very active there. It has worked over the past year, and it's not just MindsDB, but it's MindsDB as the people that code the core of MindsDB, but there's people writing integrations, people providing feedback. So we think that at the end, from feedback to contributing code is what makes MindsDB what it is. So please join us there.
Yeah, thank you. And I want to thank everybody who joined this webinar today. Thank you for your questions, for your activity. Really big pleasure to host this event for you. Hope you find it useful, and see you next time. Bye-bye.